Here we are given a value for the variable c. C is given as a cos theta minus b sin theta. Using this information, you have to prove that this equation holds, or in other words, the LHS is equal to the RHS. Now, how do we start? How do we proceed? You see a c square here. We know what C is. So let us start with the RHS. We will start with the RHS and we will prove finally that this RHS is equal to the LHS. So how does the RHS look like? You need a C square for that. So how do we get C square? All we have to do is square this equation. Then how do you square this part? This is of the form x minus y. So when you square it, how will it look? It will look like this. It will have 3 terms. So instead of x, we will just write a cos theta and we will see how it looks. Now let us see how our RHS looks like. As I said, forget about the square root. We will first see how the terms look like, then we will worry about the square root. So what we need is an a square plus b square. Add that, and to that what do you do? Take the c square and change all the signs of each one of its terms. Why are we doing that? You see a minus c square here. So take the c square, change all the signs, then you get such a term. Here what do? Isolate a square. Whatever comes with a square, put it separately. Why are we doing that? We are trying to get the LHS. In the LHS, what do you see? You see a sin theta. How are we going to get that? Here we have, with a square, we have 1 minus cos square theta. From this, how do we arrive at this? How are sin square theta and cos square theta related? How are they related? Their squares added will give you 1. Which means what? If you take 1 minus cos square theta, that will be sin square theta. And if you take 1 minus sin square theta, that will be cos square theta. See, that is exactly what we have here. So shall we substitute these values here? There, once we substitute the value, our expression looks like this. What do you have here? You have a square of one term and square of another term. And what is the third term? The third term is 2 into this term into that term, or in other words, it is in the form x square plus 2xy plus y square. And what is that? What algebraic identity is that? That is equal to x plus y, the whole square. Now we know that the square of this is equal to a square plus b square minus c square. But then that is not what we want. We want just this term, not its square. So what do? Just take the square root on both sides. Then what do you have here? Just these two terms. And here what do you have? Plus or minus square root of the term that we started with. Now you can start from the LHS also. Starting from the LHS also, you will arrive at the RHS, but it is a bit more long-winded. If you want, I can show you that. But anyways, we will see how that looks, because not everyone is going to start with RHS. So even if you start from the LHS, don't worry, you will still arrive at the answer. How do we do that? But remember, it is always difficult to get a square root. So even if you see the square root, always deal with the square. Square the number and then try to arrive at an answer, because it is very difficult to deal with a square root. So try its square. So when you square it, you have such an equation. But what are we looking for? Our final answer needs to have just a plane A. Out of this term, how will you get a plane A? You will get that only when you put, instead of sin square theta, you put 1 minus cos square theta. Similarly, from this term, finally we need to get a plane b square. How will you get a plane b square? Only if you have a one term, only then you will get it. So instead of sine square theta, substitute it like this and then open the brackets. See, you have got a plane a square and you got a plane b square. Bring them to this side, to the front of the equation, and then group all of this together, and what do you see? This is exactly what we need. Then find the square root. You will arrive at the equation. That's all for today. Take care. Assalamu alaikum.